This is the free stream when it was coming. It touches the wall. Of course, this is the first time it touches the wall. You can see what is happening because of the force encounter with the wall, and it's being transmitted to the free stream. And you can see what happened. This form, the boundary layer form, due to the transfer of momentum by a molecular motion. So, okay, so recall that for a velocity boundary layer, if a uniform flow of velocity v stream becomes incident on a flat surface, for instance, the velocity of the fluid at the surface becomes what? Instantly equal to the velocity of the surface. And the velocity of the surface v1. If v1 is not equal to the incident flow, if it's not equal to this one, if the v1 is not equal to this, if it's not equal to this, then the force exerted by the wall on the fluid at the surface to achieve the above equality condition is transmitted to the rest of the fluid through momentum transfer by molecular motion. That's a laminar flow with diminishing effect further away from the wall. Okay? So this results in the development of a region of the flow near the wall or surface, within which the velocity of the fluid changes from v wall to v stream or v incident flow. And what we call that velocity is what? Vx. So this boundary layer thickness is defined such that for 0 less than equal to y less than equal to delta, then this happens. 0 is less than Vx minus V1, less than C into V free stream minus V1. For this greater than V1, V stream greater than V1, or 0 less than Vx minus V1 all over V stream over minus V1 less than C. Or, and the 0 is less than Vx less than C, V stream. Or 0 is less than Vx over V stream less than C. For V wall is equal to 0, that's for this one. If V wall is not equal to 0, that's this one. If V wall is equal to 0, that's this one. Where C is equal to 0.99 as chosen by convention. So,
when V wall is not equal to 0, and when V wall is equal to 0, this has the same thing.
yeah. So for external flow such as flow over a flat plate, the boundary layer increases with x. You can see the x direction. The x direction is this way. The boundary layer increases with x. So in the case of internal flow, an x star exists such that for x less than x star, the velocity boundary layer is said to be what? Developing. This means that for x less than x star, the dimensionless velocity becomes this. Question 4.2. For that, Vx minus V wall, Vr all over Vr minus V wall. For this is a function of this and this. Where Vr is a reference velocity, it may be the center line or mean velocity. If V wall is equal to 0, that's the stationary wall, then this happens. You can see this V wall is equal to 0. You can see V wall is now equal to 0. So we now have this. And it's a function of this, x over L, comma y over L. For x less than, it's only a function of this for x and for internal flows, my friend. For internal flow, for x greater than x star, for internal flow, the boundary layer is fully what? So Vx minus V1 all over Vr minus V1 is a function of this because it's a fully developed flow. So, or Vx over Vr equals to is a function of this y over the boundary layer only if v wall equal to 0. That's only if this equal to 0 equal to 0. It is this is a function of y over delta because it is fully developed. No more, this one will no more be there. Then if v wall is equal to 0, this is equal to 5.